The more severe it is, obviously, the bigger impact you're going to have if you're going to address these issues. Harmonics do influence the power factor of a specific site. Hi, I'm Eric from Alpha Power Solutions, and today we'll be talking about the difference between power factor and harmonics. Well, power factor correction and harmonics are actually two separate concepts altogether, but they get confused by many people. And I think it's important today that we try to explain the two concepts or the two phenomena and how they actually interact with each other. But actually, they're two separate things altogether. Let's start with harmonics. They're basically a form of electrical pollution that are caused by non-linear loads, such as VSDs, UPSs, soft starters, inverters, LED lights, and all that type of equipment that actually doesn't take the whole sine wave of the electrical supply, but take chunks out of it. By doing so, you create secondary frequencies that we call harmonics, and they can be quite destructive. A power factor, on the other hand, is a measure of how efficiently a site uses the power it draws from the grid. So a poor power factor typically indicates that the site is drawing a lot of reactive power from the grid compared to the amount of active power it draws. So they're two separate concepts, really. Harmonics do influence the power factor of a specific site. Like I explained before, harmonics is basically a power quality issue. The harmonics present in a system will actually cause distortions of the voltage and the current waves. And when it comes to the voltage supply wave, that distortion leads to higher peak-to-peak voltages, and that can result in insulation failures, failure of electronic components, and other negative consequences of these harmonics. When it comes to the current harmonics, well, basically they increase the total RMS current that is being drawn from the grid without there being any additional kilowatts being drawn. So you're going to get higher cable losses, you're going to have transformers overheating. There's many consequences of that high current or these harmonic currents, including skin effects, or basically where the electrons in the conductor are pushed to the outside of the conductor so that you have a fairly high current density on the outside and very little in the middle. So the result is that cables start to overheat even though the total current in the conductor is actually correct for that size cable. But because of that skin effect, the cables do overheat. Now, when it comes to power factor, again, a poor power factor will result in overloading of supply transformers, of generator alternators, basically the supply to the factory because of the amount of reactive power that's being drawn from the grid. So it results in higher volt drops on the cables and supply transformers, causes overloading of the whole supply system, can cause an overloading of the whole system. And so as I explained before, harmonics, or especially current harmonics, result in high RMS currents. So that means that more apparent power is being drawn from grid. That means as a result of that, you're going to have higher losses, higher demand-related charges from the utility company, and a reduced life expectancy of all the equipment that's related to the actual supply of power to a specific site. When it comes to power factor conditions, then obviously there's higher demand and reactive power consumption charges. Again, also higher losses in cables and transformers. It can also result in poor power factor penalties in certain countries. Certain utility companies levy these penalties. And again, also reduced life expectancy of the equipment related to the supply of the grid. Typically talking about the supply transformers and all the cables from the supply transformers to the distribution board, that portion of internal reticulation of a factory. Well, combining power factor correction equipment with harmonic filtration helps basically do two things. One is obviously improve the power quality of the site, but then as a result, you also reduce the electricity bills, get longer life expectancy of electrical and electronic equipment, less electrical failures, less wasted energy. So the effect or the positive impact you can have really depends on the uncorrected power factor of the site. What I mean is, before you do a power factor correction intervention, what is the power factor of that particular site under peak load conditions? So it really depends how bad the power factor is and how bad the harmonic content of a particular site is. So the more severe it is, obviously the bigger impact you're going to have if you're going to address these issues. If power factor is not ideal but not bad, or if the harmonics are present but not extremely bad, then obviously the impact will be much. Similarly, then the investment required to fix the easier sites or the sites with less problems also lower. So the only way to find that out is actually to do an audit, use specialized test equipment that can measure harmonics, that can measure power factor, and ideally you probably would need a power quality analyzer. As it's always a safer bet to have a recording of at least a week to see what happens in a factory during peak load conditions, after hours, during weekends. So you get a better picture of what the power usage and the harmonic content looks like under different time conditions. So the data you obtain from those exercises is actually invaluable because it helps you identify the problem. And once you know what the problem is, you know what the solution is. So yeah, you can once you have the data, you can determine the cost to fix the problem. You can also calculate return on investment because you have all the data to be able to do that. When it comes to harmonic filtration, the calculation of the ROI or the payback period is more complicated because basically, if you're in an environment where the harmonics have been present for a while and the harmonics have been abusing the electric and electronic equipment installed in a factory for a number of months or years, when you then suddenly clean that all out, it doesn't mean that all your premature failures will stop suddenly because the equipment was already abused for a long period. So calculating that, the ROI of a harmonic filtration system is more complicated because you have to make a whole bunch of assumptions. But over time, if the company, if the client has got accurate maintenance systems in place where they can see the life achieved on critical components, they will definitely see an increase or improvement in the life that they get out of their equipment. Well, thanks for watching. If you found this helpful, please like and subscribe. There's a blog with more info linked in the description below.